Alright, please pay attention here. These are the materials you're going to need for this lab. Okay? You have packages of metals. The one on top here just happens to be zinc. You're going to have a package for silver. Lab captains, whoever you happen to be for this lab, there should be 5 pieces of silver in here. You're responsible for them. Okay? When you're done, if they're not reacted, they need to be put back in this container, in this plastic bag. Okay? Silver is very expensive. We try to take care of the environment, and we try not to use more than we need to. Okay? So any silver that's not reacted needs to be back in here. I'll talk about how to do that in a minute. Okay? You've got some copper and manganese. Now, the manganese may be in a strip like this one right here. You just have to cut it into small enough pieces, like this little tiny piece I got in the corner down here, if you can see it. Okay? So it'll simply fit into the wells. This is a well plate. Alright? And all you're going to do is you're going to take and put pieces of metal down inside the well plate. Alright? So I've got a chart made out for you to make this fairly easy for you. So I've got zinc here with an arrow. So what that means is that in each of these wells, you're going to put a little bit of zinc. Now you don't need to put it in this last set over here on the right because we don't have a solution to go in there. Alright, so you really 5 things of zinc, 5 things of silver, 5 things of copper, and 5 things of magnesium. You only need a small amount, just enough to see if there's a reaction. This is a more observational type of lab. It's not a quantitative lab where you have to do a lot of measurements. It's more observation. Now, you only need as much of the solutions as you need to cover those metals. So when you put a piece of metal in the bottom or some of those little chips of metal or whatever down there, all you need to do is cover it with the liquid. You don't need to fill up the whole well or fill it up halfway, just enough to cover it so you can see if there's a reaction enough or not. Does that make sense? Okay. Now, you don't have to worry about zinc because it comes in little chips. You don't have to worry about the copper too much because it'll either come in little beads or it'll come in little strips. But for the magnesium and the silver, you need to make sure you've got at least one shiny side, and that side is up in here. Okay? Now that's why on each one of these lab setups you've got this stuff. This is called emery paper. It's kind of like sandpaper, only it doesn't wear out nearly as fast. Okay? Emery paper.
So if there's no shiny side,
you want to make sure you take that piece of metal and shine it up. And that's why each one of these setups is supposed to have, well, I take that back, I don't have a set of pliers for everything, but you can borrow them from somebody else if you need to. Okay, I've got 4 pairs of pliers. One lab group some time ago apparently left one completely wet and it rusted over. I can't fix it. And somebody stole a pair apparently, I guess. So, anyway. That fast? I had them for several years. Well, if you do it in the spring and it sits in there damp over the summer, yeah, it can rust up pretty bad. Okay? No. I've fixed some others where I spray some oil on it and work it and stuff and get it going again, but, you know, I mean, I've only got so much money. I don't go buy stuff in the hardware store if I don't have to. Okay? So there's 4 pairs of pliers back there. Borrow one if you need to. Just get it back where it came from. Okay? All right. So this is a fairly simple lab. Everything's kind of laid out for you. It's an observational lab. You can do about 4 of these at a time, but don't put metal in every one of these wells and cover all of them with fluid at the same time. Because if you do that, you won't be able to observe everything. Some reactions may be gone and over with before you get back and look at it. You might want to put zinc in all these and silver in all these, copper in all these, and magnesium in all these, and just fill up this set of wells with zinc nitrate and observe carefully. And then fill up this set with silver nitrate and so forth. But make sure you're paid attention to some reactions happen fast, some reactions happen slow. So just be careful to observe, okay, and don't get ahead of yourself, but don't go too slow either. All right, we got other things we need to do in the class. Any questions about what you're supposed to do? When you're done, as I said, we want to collect any of the unreacted metals. So what you do is you get a paper towel or two and set it down in the sink. Then take your well plate and just simply turn it over and tap everything out of there. Okay? Then when you lift it up, whatever unreacted metals are should be right there on a row where you can pick them up. And you'll notice you should be able to tell what they are at that point. You've worked with them enough. Okay. Any unreacted metals need to be picked up. It'd be good to rinse them off, put them back in the bag they came from. All right, we'll try to keep everything that we can keep. Yep.
If they do react, are they going to dissolve?
They might dissolve, or they might leave some kind of residue. You know, anything left over that after you've collected the metals, any of the unreacted metals are collected, then everything else left on that paper towel you can simply wad up and throw away.
Right.
And then you want to rinse the liquid down the sink really good because you don't want to leave any of these solutions in the piping where it can rust the pipes and such. All right, everybody clear? Any questions? So all that should be pretty much in your procedures. As your second exposure to it, you should know what you're doing now. Okay. So the post lab for the single replacement lab takes into account what you did a couple nights ago with this homework sheet, where you're supposed to take a look at this metal in these solutions, this metal in these solutions, predict what was going to happen, and explain why you think it's going to happen. So those are all single replacement reactions. You're supposed to predict the results and explain why. And it continues on the other side. Then, in your lab notebook, before you did the lab, you're supposed to put this chart in there, which looks a lot the same except for the fact that this says prediction and explanation. This is observation, and then explain why it's different if it is different. So what I want you to do is, this should be much, much bigger in your lab notebook. It's just an outline for you to follow. So you have enough room for observations and enough room for the conclusion, basically, over here for each one of these reactions. So you should take a look at, when you put zinc in zinc nitrate, you write the observation during the lab. Then you're going to go and look at what you wrote up here on the sheet for zinc and zinc nitrate. You predicted whether it was going to happen or not and why. And then here, you want to say, okay, the results, the observations I took, they either supported what I predicted earlier, or they refute what I predicted earlier. Okay, either what I saw in my observations seemed to look like a reaction if I predicted, or doesn't look like a reaction, and that's what I predicted or not what I predicted over here. Okay, and then if it does support your prediction, that's all you really have to write. However, if the results in your observations seem to refute what you predicted, then what you're going to say over here, in addition to the fact that you're going to say the results, the observations refuted what I predicted, you're going to explain why you think that might have happened. Did I make an error in my prediction? Was it a lab error? Or, I have no earthly idea. But you should have some idea for most of it. There should be some reason why you can indicate if it wasn't what you predicted, there's a reason why. And what you want to look for is a reason why. Okay, you shouldn't say every time I have no earthly idea, because that's just not trying. Okay, occasionally somebody might say I have no earthly idea, but most of the time you should be able to figure out something about why your results weren't what you predicted they would be.